Ladies and gentlemen, good morning everyone. It is my pleasure to present my paper entitled Algebraic System with their applications of bipolar, fuzzy, row and row bar ideals semigroups by Dr. Shukr Mahmoud Khalil and Mr. Ahmed Naji Hassan. Here in this paper, new structure of bipolar fuzzy ideals in algebraic semigroups are given. Some new concepts such as row semigroup, row subsemigroup, row ideal semigroup, row bar ideal semigroup, and row semigroup homomorphism are investigated. Furthermore, some notions of fuzzy logic like fuzzy row subsemigroup, fuzzy row ideal semigroup, fuzzy row bar ideal semigroup, bipolar fuzzy row subsemigroup, bipolar fuzzy row ideal semigroup, and bipolar fuzzy row bar ideal semigroup are introduced. Also, some basic characterization of our IDs are studied and discussed. In classical sets, it is not necessary every row ideal is row bar ideal. However, in this work, that possible for their extensions in non-classical sets, like fuzzy sets and bipolar fuzzy sets, with the new their form in algebraic semigroups. In this work, the row semigroup homomorphism image and the Cartesian product of bipolar fuzzy row and row bar ideal semigroups are studied their applications. Furthermore, some notions of fuzzy logic like fuzzy row subsemigroup, fuzzy row ideal semigroup, fuzzy row bar ideal semigroup, bipolar fuzzy row subsemigroup, bipolar fuzzy row ideal semigroup, and bipolar fuzzy row bar ideal semigroup are introduced. Also, some basic characterizations of our IDs are studied and discussed. In classical sets, it is not necessary every row ideal is row bar ideal. However, in this work, that possible for their extension in non-classical sets like fuzzy sets and bipolar fuzzy sets. With the new their form in algebraic semigroups, in this work the row semigroup homomorphism image and the Cartesian product of bipolar fuzzy row and row bar ideals semigroups are studied their applications. Definition 1. A row semigroup is a non-empty set chi with two binary operations circle and sharp and fixed element L such that these three conditions. The second definition about row subsemigroup. Let D non-empty set subset of chi and chi be row semigroup. We say D is a row subsemigroup of chi if for any two elements in D such that omega circle theta and omega sharp theta also belongs to D. The third definition about rows ideal semigroup. Let D non-empty set and subset of chi, where chi is row semigroup. We say D is a row ideal semigroup of chi if such that two conditions. The first condition, D is an row ideal of chi. The second condition, for any two elements, the first one in D and the second one in chi, their product by two sides under sharp also belongs to D. The fourth definition about row bar ideal semigroup. Let D non-empty set and subset of chi where chi is row semigroup. We say D is row bar ideal semigroup of chi. Also, if it such that two conditions. The first one, D is an row pair ideal of chi, and the second condition for any two elements, the first one in D and the second one in chi, also their product under sharp by two sides also belongs to D. Here in this example, we consider that chi with two binary operations, circle and sharp, with fixed element 0 is a row semigroup. In other side, the set G, which is contains 0, 1, is row ideal semigroup of chi. However, this set is not row pair ideal of chi, since 1 belongs to G and 3 belongs to chi, but 1 circle 3 equal 2 and 2 does not belong to G. Hence, G is not row pair ideal semigroup of chi. This remark shows that from above example, we consider it is not necessary every row ideal semigroup is row pair ideal semigroup. Here we will introduce some new concepts of fuzzy logic. Definition 6. Talk about any fuzzy set in row semigroup. It is called fuzzy row subsemigroup if it such that these two conditions. Definition 7. Talk about any fuzzy set in row semigroup. It is called fuzzy row ideal semigroup if it such that these three conditions. Definition 8. Talk about any fuzzy set in row semigroup. It is called fuzzy row pair ideal semigroup if it such that these three conditions. In this work, we introduce this lemma, and by this lemma we consider that in non-classical set in fuzzy setting, we can consider that the relation between row ideal semigroup and row pair ideal semigroup, where in this work, by this lemma, we can consider that every fuzzy row ideal semigroup is fuzzy row pair ideal semigroup. However, it is not necessarily true in classical set. That means there is no any relation between row and row pair in classical set. Here we will introduce some new concepts of bipolar fuzzy semigroup. Definition 9. Talk about any fuzzy set. It is called bipolar fuzzy row subsemigroup if it's such that these two conditions. Definition 8. Talk about any fuzzy set in row semigroup. It is called bipolar fuzzy row ideal semigroup if it such that these three conditions. Finally, definition 11. About any fuzzy set in row semigroup, it is called bipolar fuzzy row pi ideal semigroup if it such that two conditions. This lemma shows that every bipolar fuzzy row ideal semigroup is bipolar fuzzy row pair ideal semigroup. Therefore, we consider this remark. From above lemma, we consider a non-classical set as bipolar fuzzy setting. This lemma is true. However, in a classical set, that's not necessary this lemma is true. Furthermore, some propositions and lemmas are introduced in this work about these definitions. All of these propositions are interested in fuzzy logic. We applied the homomorphism image and the Cartesian product of our notions in this work. Thank you.